Hello. In this video, I want to discuss the concept of generalization. The concept of generalization is at the heart of the scientific field of machine learning. We may even define machine learning as the study of computationally efficient methods for generalizing from data. Let me start to explain what generalization is with the help of a game that many of you might have come across during school time. This game consists of extending a given sequence of objects, for example, a sequence of numbers. In machine learning, we often refer to these individual objects or elements in a sequence as a data point. Here we have a sequence of 5 numbers, 4, 5, 6, 7, and 8. The goal is to guess or predict the next element in the sequence. Generalization here means to be able to produce a good guess for the next element in the sequence. Let us consider another instance of the sequence guessing game. In contrast to the previous game, here the sequence elements or data points consist of 2 parts. The first part is known as the features of a data point. In this case, it is a geometric figure. The second part of each data point is a number, which we refer to as the label of this element or data point in the sequence. Here, the goal is to guess the label of a new data point or a new sequence element for which we are given the features of that data point. We could also phrase or frame the task of learning addition as a form of generalization. Based on some elementary examples for the addition of 2 numbers, we would like to predict or guess the result of adding any new 2 numbers. A very timely example or application for the sequence guessing game is the forecasting of COVID-19 infections. Here, each sequence element or data point might represent some day during the pandemic. We could then use different epidemiological indicators as features for a particular day. The label of some day or a particular day might be the number of confirmed COVID-19 infections that we expect 1 week later. The goal in this sequence prediction game is to predict or guess the number of COVID-19 infections 1 week ahead in order, for example, to optimally plan healthcare services. Here is yet another instance of the sequence guessing game. This guessing game here depicts one of the most popular applications of modern machine learning. That is, to predict if a given image shows a cat or if a given image shows a dog. Machine learning methods solve this task by playing a form of a sequence extension game. These methods are provided a typically very large number of sequence elements or data points for which we know the true label, so for which we know if the image shows a cat or a dog. And one key factor for the success of modern machine learning methods is the availability of large amounts of such labeled data points. So we can start from a very large or long sequence of data points for which we know the labels. So now that we have looked at several instances for a sequence guessing game, can we find some general approach or principle to solve such games? The answer is yes, and in particular, machine learning, very similar to human learning, uses a very simple but powerful principle to solve many different kinds of sequence guessing games. This principle is based on forming a hypothesis. Consider again the sequence we have already shown in the beginning. This sequence starts with 5 numbers: 4, 5, 6, 7, 8. The question was, what could be a good guess for the next element in that sequence? And just by looking at the first 5 numbers, many of you might have already formed immediately some hypothesis or assumption or model for the underlying sequence. Indeed, this hypothesis, or one possible reasonable hypothesis, could be that the sequence elements are linearly increasing according to a straight line. And once we have formed such a hypothesis, in this case, the hypothesis of a straight line, we can use that hypothesis to predict the next element in the sequence by continuing the straight line. This very simple example illustrates the very principle of many successful machine learning methods. Machine learning methods learn a hypothesis for the intrinsic structure in observed data. And using such a learned hypothesis, a machine learning method can form or compute predictions or forecasts about new elements in the sequence or future data points. If you want to learn more about machine learning and how it uses hypotheses to generalize from observed data, I highly recommend the upcoming bachelor level course, Machine Learning. This course is offered at Aalto University and via the Finnish university network phytech.io. You can also read more about the basic principles of machine learning and generalization in my textbook, Machine Learning: The Basics.